In general, you need something that knows how to read those binary files. This is generally why we have specialized applications for these things, like Photoshop or God knows what else, right? The only thing that's human readable is something that you can display in Notepad. If you can't display it in Notepad, it's probably binary. That's the easiest way I can think of to describe it. So just understand binary data exists. We need an application to open it. Generally, images and sound. That's the only thing you need to, those are the main things in deep learning that you're probably going to be dealing with in terms of input data. Binary data, like I said, can also be protobuf though. Binary data is a lot more efficient than text data. So text data, there's a cost to human readability actually. A very, very big cost. So this is why we generally use binary formats for everything instead of, so remember when I mentioned earlier that like HTTP is verbose? It's because it's a lot of it's text-based. It's a text-based protocol. So use binary wherever you can. Okay, so preprocessing / vectorization. As I mentioned earlier, you need a process remotely on the server that takes the raw data. You know, if you upload a file, just think of it. You click upload file. That is the easiest way. That's the easiest form of input data I can describe that you would understand with point and click, right? You upload a file. Somehow that file has to be sent to a server. Somebody has to download it and then load it on the server, right? And now you have a text file. Okay, but that's not something you can use with scikit-learn, unless somehow you have a TF-IDF vectorizer or something already there, right? You have to have some form that says take data, transform to matrix. That's called vectorization or preprocessing. Preprocessing is also an overloaded term though, because sometimes you might want to take the text data and then maybe you'll scale it 0 to 1, right? This is why we call these things pipelines, because there's usually a series of steps to get it to a desirable vector, a desirable target vector, directly applicable to a machine learning algorithm, where you call predict. Generally, 99% of the time, that's going to be a NumPy array of some kind. Right? So these are all things you've probably done locally to verify the accuracy of something, where you call predict and you get back like an F1 score. That generally you're running some sort of preprocessing to get it to that. Sometimes if you're running machine learning, maybe you pre-save a test set with a pre-saved matrix already. But either way, your data doesn't start in a form that your data, unless you're using MNIST, doesn't start in a form that you can directly use. The exception to the rule is like Keras.datasets pre-does that process for you. Kaggle sometimes does that, but generally you need some sort of a pipeline. If you've ever dealt with pandas, sometimes pandas is your pipeline, right? Like, but you need a df is equal to blah, df equal to blah, and somehow you get a NumPy array, right? So that's another way to think about transforms. But either way, you need something that takes that raw data, transform it, right? And that's a pipeline. Next is a model server. So again, a model server just has the model in memory. It loads it from disk. You have it in memory, and you can send data to it remotely. So it's a combination of a model in memory plus, so basically a way of connecting to a model could be TF serving, or it could be over just REST with flat. There's multiple ways you can do it, right? That's all using client server. So a server just responds to remote requests. And usually on the server, you have the logic for preprocessing, and you have the logic for running the model, right? And you get that NumPy array out. So that server sometimes has very special requirements. So for example, if you upload 5 images at once, then you're gonna create a batch size of 5, right? So for example, what does the batching? The server, or do you directly send a NumPy array over the client? Generally, you're going to use the server. So the server will take the 5 images, create one NumPy array, run one prediction at once, right, and then return 5 results. That's the most basic form of a concept you can think of in terms of what a model server can do, right? Sometimes you're limited to 1 at a time, right? So you upload 1 image at a time only. It depends. It heavily depends on what your model server is, right? Like generally, I know sometimes we're playing in Python, we're playing in Jupyter, and we only have access to we're only running like F1 score and like train test split and all these other magic things that just exist in experiment land, they don't exist the second you get into production. Somehow you need to reinvent all that. So somehow you need to approximate all that logic. That's generally what a model server does. So again, 99% of the time, it's probably over rest. Another one is, like I said, TF serving uses gRPC. It's actually a binary protocol. So it's an alternative to HTTP. Because again, like I mentioned, HTTP can be verbose. Finally, we get to transactional serving. So this is where you send a request, and if you think of your web browser, like you're generally waiting on a response, right? That's transactional. That means you're waiting on the result in real time. So that means you have a credit card. Think of it. So where transactions come from. Think like a credit card swipe. Your credit card swipe happens in real time, and somehow you're doing fraud detection. Actually, machine learning algorithms. Every time you swipe a credit card, a machine learning algorithm is actually run generally, depending on the bank. They will actually have or sometimes it's a rules engine. It depends. But that's a transaction. So you have one transaction. It scores within milliseconds and returns a result in real time. That's transactional.
If you're talking about Japan, it will be a rule engine.
Sorry?
If you're talking about Japan, it will be a rule engine.
Yes. Not arguing with you. Batch serving. So that's the other one. Batch is where you say, I just want to run. Actually, batch is what you do every time you train a model. You're doing batch inference because you're doing everything offline. So that means you're just running it in a script, and then you just save the result for later. So what you'll generally do is you'll generally schedule it, and you'll run it on something like Spark or what have you. That's batch, right? Like what's an example of batch? What's a typical example of batch? Recommendation engines. So it turns out recommendation engines are actually not real time. Actually, they pre-compute the whole. If you've ever done collaborative filtering and God knows what else, actually what you're doing is you pre-compute everything for all users, and then you serve the results from a database. So a lot of graph algorithms as well, like LinkedIn, for example, whenever they recommend you friends, those are actually large-scale batch jobs. That's why so like Uber and all these other companies, they run batch jobs every night. This is what data engineers generally do. They load a terabyte of data, the last 24 hours worth of data, they run all the results at once, and they do it on a distributed cluster of like 5 or 6 machines, and then they store the results in a database of some kind. And then they serve the results from the database. And then serving is actually an SQL query. So it looks transactional, but it's actually not. Everything's pre-computed the night before. That's how you do large-scale that's actually how you do large-scale nearest neighbors queries and things of that nature. You pre-compute it on a distributed cluster. Like I said, the simplest form of it is every time you're running your IPython notebook, you're not doing transactional, you're doing batch. Right? So a batch job can be as simple as computing an F1 score on a mini batch of data. That's literally batch. Like, so you're doing that offline, and then sometimes you save the results. Saving the results could literally be display it in the IPython notebook and save it. That literally could be all you're doing, right? But that's batch. But batch generally involves some form of distributed systems or a really big machine you turn up, you spin up, you run all your results like this is what these big on-demand machines are for actually. Or if you run anything like SAP HANA or some of these other like big like multi-terabyte memory databases, they're usually used for batch jobs. That's what these on-demand things are for. So you can run these large-scale batch jobs for cheap, because you only need to store the results. Sometimes you might be storing these things maybe in S3. The kind of thing we're going to be doing today is just transactional serving over a simple REST API. 99% of the time, this is all you need. So your application just responds to cat or dog, or whatever equivalent thing you're trying to do, or fraud or not fraud, churn prediction, whatever your use case is. Generally, that's going to be transactional. You generally don't need batch serving unless it's for very specific use cases. Any questions around that? Go ahead.
Let's say if we want to use the real-time data
Yep.
on the training set as well. Let's say if I just swipe a card and then I want to add that data point to
Yep.
my training data set. So how does that?
So statistically, you may want to do that because you generally, if you're doing incremental online learning, sometimes your batch sizes are going to be batches are going to be biased, just like they would be in your training set.
Actually, you can do it like
There's always caveats. There's 5 billion caveats. Don't worry about it right now. Google search, if you want to know how to do it, there's a whole set of terminology called the Lambda architecture. So what I will show you is just how would it look like in practice, and how do I research this stuff. So the Lambda architecture is this is generally how you do online learning, right? This is how you set up a general purpose system to do it. So yes, there are all sorts of ways you can do online incremental learning, depending on the model, depending on how you do the mini batches and everything else. Generally, Lambda architecture is how you do it. So an example of that, like based on Spark, for example, is called Oryx. Oop, not that. Let's see. Here we go. There you go. See? There you go. There you want stuff open source? Download it and go ahead and download it. Lambda architecture for Spark and Kafka. Real time everything. It's written by some Cloudera folks. It's just a personal project though of theirs. But it actually has users. So this is an example where you're doing like the real time, where you're doing serving, you're doing streaming inputs, you're doing batching and everything. It's all here. Right? Like so this is so what are we doing end to end here? We're taking in some data, we're streaming it, and then we have a way of updating the model, and usually in real time. So why is this complicated? Well, for example, one of our bigger users, they rebuild their models every couple of hours because they get fraudulent comments. So they have to implement a system like this because they have a high frequency of input data coming in, right? Like so, what are they doing? Well, sometimes they're using Spark, sometimes they're using something else. But generally, what they're doing is they have a layer for taking the input data, running some form of training, and then what they actually have to do is they actually have to do kind of like a distributed lock. Because otherwise you have, if you're in distributed systems, you have you have this idea of a stale read. So a stale read is when you ask for an answer from an out of date part of the system. So imagine you have a model that was just trained 5 minutes ago. Somehow you need to get that model that was just trained on 10 different computers, right? Because 10 different computers are responding to the same requests. And so how do you know when your answers aren't going to be disjoint? Right? That's one of the most common problems you run into in distributed systems. How do you know two computers are going to respond with the same answer? That by itself is a hard problem. This is why you have something like the Lambda. This is why you actually have something like the Lambda architecture. Again, you don't need to do this. It's generally hard, and it's generally too hard to get right. You can do it, but caveat emptor for whatever your use case might be. Like I said, so if you're doing online learning, batches are general. The distributed systems part is hard. Statistically, that's where you folks might have more opinions, like on what a balanced batch size can be, how often you do the updates. Generally, when you're doing online learning, actually online video is probably one of the bigger use cases. If you want to do that, generally you generally, just like you would in GPUs, you generally batch the video and you get a queue. And then you run the and then you run the training, and then you update the model. Because otherwise, if you're just sending in one at a time, you're not going to get. It's going to be too slow, right? So when you add GPUs into the mix in this, distributed systems plus GPUs and batching in the use case, that's where you say it gets very specific. So I'll answer specific questions on how you want to deploy these things, depending on what you want to get into. When I said edge cases, this is what I'm talking about. Things running out of memory. Two computers returning the same response. Basically, when you get into clustering, the second you've got more than one computer, you have a problem. Which is why we're focusing on just one node here today. Most of the time, you don't need this kind of stuff. Just know this exists. Okay. You wanna anything else you wanna add? Okay. Cool. So again, if you have specific questions on for images, vision, video, speech, time series data, happy to do that offline. So again, just know this exists. Don't worry about it. For the most part, the ones you're going to encounter are generally batch and simple REST API calls. 99% of the time. I'm just giving you something you can Google search later if you want to know how some of the stuff is done at larger scale. Okay. So back to the Docker container. Did the Docker containers all build? So it should say like successfully something. Okay. So we're gonna go back. We're gonna do the next one now. So the next one isn't gonna take as long. So you're gonna want this one. Server with metrics computer vision. This is gonna be the final folder you get into. So again, it's in that same pipelines folder. Server with metrics computer vision. This has that Docker compose file and then some other stuff in there. So what's in there? Well, so there's a Docker file in there, and what is it? Well, don't worry too much about this. This is just the default username for the Jupyter notebooks. But the main thing is, what am I doing here? I'm running pip install. So again, as I mentioned, Conda is pre-installed, and what I'm going to do is I'm going to install some specific libraries. So this is a minimal image with only Conda and Jupyter on it. So if you want to use it, then you're probably going to need to run pip or Conda install. So you'll notice I'm using pip instead of Conda. Why am I doing that? This button. Conda actually has something you should be aware of. It uses MKL by default. That can be a problem depending on the circumstances. This uses OpenBlaz, not MKL. So NumPy can be linked against different C libraries for math. You don't need to know much beyond that, but just know that like NumPy and MKL, NumPy and OpenBlaz, if you try to like merge the two, weird stuff happens. So you can't have the two on the same computer generally. So just know that there's a difference when you install NumPy from NumPy, TensorFlow, and all that from pip versus Conda. Sometimes pip is required, and sometimes another thing you run into is Conda libraries sometimes don't get along with pip libraries, and sometimes they'll clash with each other. So if you've ever seen, this is all the Python dependency file, you've probably seen it in some form before, right? Yeah, I'm sure you've all been like, why is it working? And then you get like some esoteric C error, right? That happens all the time. That's generally because of clashing libraries or clashing versions somewhere. So this is why Docker files exist, because you can make all sorts of assumptions, and then it's zipped up in its own thing, and then it's isolated. You don't have to worry about it. This is also, when you're using Conda, they recommend you install multiple environments instead. That's why, because generally Python, the way Python works is it generally assumes isolation of your environment and everything. This is why you either use virtual environments or you use Conda environments instead. But that concept of a Python environment is this set of dependencies only works for this application and this application alone. And generally, the way they recommend you do develop software engineering in Python is you have one Python environment per application. Because if you start mixing stuff, all sorts of weird stuff starts happening. That's the main thing you need to know. So in general,